Download this code from codegive.com, link in the description below. OK, let's dive into event-driven programming, EDP, in Clojure, focusing on a style influenced by Zach Tellman's approach, which often emphasizes simplicity, data orientation, and avoidance of complex concurrency abstractions when possible. We'll cover the core concepts, common patterns, and provide practical code examples. What is event-driven programming? In event-driven programming, the flow of the application is determined by events. An event is a significant occurrence that the system needs to react to. Instead of a rigid, predefined sequence of operations, the system listens for events and then executes code to handle them. Key concepts *. 1. Events * discrete, immutable data structures that represent something that has happened. Think of them as notifications or facts. 2. Event sources * components that generate events. This could be user input, sensor data, network messages, or internal system state changes. 3. Event handlers * functions that are executed in response to specific events. They consume event data and perform actions, example updating state, sending messages, triggering other events. 4. Event loop / dispatcher * a central mechanism that receives events and routes them to the appropriate event handlers. This is often implicit or provided by a library. In simple cases, it can be implemented with queues or channels. 5. Immutability * Clojure's inherent focus on immutable data is crucial in EDP. Events are typically immutable, preventing unintended side effects and making it easier to reason about the system's behavior. 6. Decoupling * EDP promotes loose coupling between components. Event sources don't need to know the details of how events are handled, they simply emit them. Event handlers don't need to know where events originated. This decoupling makes the system more modular, maintainable, and testable. Zach Tellman's influence on EDP in Clojure *. Zach Tellman's work and talks have emphasized data-oriented design * treat events as data. Focus on representing them clearly and immutably. Simplicity * avoid over-engineered abstractions. Favor simple data structures and functions over complex message passing frameworks when possible. Concurrency primitives * utilize Clojure's built-in concurrency primitives, atoms, refs, agents, channels, carefully and strategically. Avoid unnecessary locking and shared mutable state. Function composition * use Clojure's powerful function composition capabilities, example comp, partial, to build event handlers and process pipelines. Asynchronous operations * leverage core.async channels for non-blocking communication between event sources and handlers. A simple example, a basic event dispatcher. Let's start with a minimal example using core.async channels as our event queue and dispatcher. Explanation * 1. Create event channel * creates a core.async channel that will serve as our event queue. 2. Event handler * a simple example handler that just prints the event. In a real application, this would contain the logic to process the event. 3. Start event loop * this function launches a go loop, a lightweight thread in Clojure. It continuously reads events from the event channel and executes the handler fn for each event. The loop continues until the channel is closed. 4. Send event * puts an event onto the event channel. Is a blocking put operation, for simplicity in this example. Is the non-blocking version, which would be preferable in a real system. 5. Close event loop * closes the event channel, which signals the go loop to exit gracefully. Running the example *. Save the code as event_driven_example.clj and run it from your replace or terminal. You'll see output similar to A more realistic example, order processing system. Let's expand on this and create a simplified order processing system using EDP. Key improvements in the order processing example asterisk. 1. Event definitions asterisk. We use defrecord to define specific event types: order created, payment received, order shipped. This provides type safety and clear data structures for our events. 2. State management atom. We use an atom called system state to store the state of the order processing system. This is a simple way to manage shared mutable state in Clojure. All updates to the state are done using swap, which ensures atomic updates. 3. Event handlers asterisk. Each event type has a corresponding handler function: handle order created, handle payment received, handle order shipped. These handlers update the system state atom based on the event data. 4. Event dispatcher asterisk. The dispatch event function receives an event type and calls the appropriate event handler. This provides a central point for routing events. 5. Event type with data asterisk. The send event function takes both an event type and the event data. Events are now wrapped inside a map with type and data keys. This allows start event loop to extract the type and pass the data to the dispatch event function. 6. Non-blocking channels asterisk. Using is not ideal in a concurrent system. Replace this with inside a go block. Important considerations and best practices asterisk. Error handling asterisk. In real-world applications, robust error handling is essential. Consider using try-catch blocks within event handlers to catch exceptions and prevent the event loop from crashing. You might also want to log errors or send error events. Asynchronous processing for long-running or I/O bound tasks within event handlers, use core.async channels or other asynchronous mechanisms to avoid blocking the event loop. Event ordering if event order is critical, ensure that events are processed in the correct sequence. This might involve using a priority queue or sequence numbers in your events. However, maintaining strict ordering can introduce complexity and reduce concurrency. Try to design your system to be tolerant of out-of-order events when possible. Idempotency design your event handlers to be idempotent. This means that if an event is processed multiple times, it should have the same effect as processing it once. This is important for handling potential message duplicates or retries. Serialization if you need to persist events or send them over a network, you'll need to serialize and deserialize them. Clojure's data.json or libraries like Transit are good choices. Testing write unit tests for your event handlers to ensure they behave correctly. You can simulate events and check that the system state is updated as expected. Consider using generative testing to cover a wide range of possible event data. Tracing and monitoring implement tracing and monitoring to track events as they flow through the system. This can help you debug issues and understand the system's performance. Bounded contexts in larger systems, consider breaking the system into bounded contexts, each with its own event loop and state. Use domain-driven design, DDD, principles to define the boundaries of each context and the events that flow between them. Advanced topics CQRS, command query responsibility segregation, a pattern where you separate the read and write sides of your application. Events can be used to update the read models, queries. Event sourcing instead of storing the current state of the system, you store a log of all the events that have occurred. The current state can be derived by replaying the events. Stream processing use a stream processing framework, example Apache Kafka Streams, Apache Flink, to process events in real time. Distributed event buses for distributed systems, you might use a message queue or event bus, example RabbitMQ, Apache Kafka, to transport events between different services. Example of asynchronous event handling. Let's modify the order processing example to handle the shipping event asynchronously. We'll simulate a long-running shipping process. Changes asterisk. Asterisk new events asterisk shipping started and shipping completed are added to represent the start and end of the asynchronous shipping process. Asterisk asynchronous shipping asterisk the handle order shipped event handler now launches a go block to simulate the shipping process. This process waits a random amount of time and then sends a shipping completed event back to the event channel. Asterisk event dispatcher asterisk the dispatch event function now takes the event channel as an argument, allowing it to send events back to the loop for asynchronous operations. Asterisk non-blocking sends asterisk the send event method uses, instead of, so that events are passed to the channel non-blockingly. Explanation of asynchronous shipping asterisk. 1. An order shipped event is received. 2. The handle order shipped handler starts a go block. It also sends a shipping started event to update the state to shipping. 3. The go block simulates a long-running shipping process using timeout, randint 3000. 4. After the simulated shipping process completes, a shipping completed event is sent to the event channel. 5. The shipping completed event is handled by handle shipping completed, which updates the system state with the tracking number. This example demonstrates how to use Clojure's core.async channels to handle asynchronous operations within an event-driven system. The main event loop remains responsive, and the long-running shipping process is executed in a separate coroutine. Conclusion. Event-driven programming offers a powerful and flexible approach to building complex systems in Clojure. By embracing immutability, data-oriented design, and Clojure's concurrency primitives, you can create highly modular, maintainable, and scalable applications. Remember to focus on clear event definitions, robust error handling, and asynchronous processing where necessary. Keep it simple and iterate. Good luck.